Now we are coming to another paradigm. Okay. So, I did cover many ways to make your code efficient. So, first was sequential code itself could be made efficient, right, by using comparer option. Then we used JIT, Numba. Okay. I think Numba is great. Numba is take the same code and you can do it. I want to tell you that NVIDIA, in fact, NVIDIA is doing lot of very good things. So, NVIDIA is trying to come up with a strategy, so that your sequential code can be run on n number of GPUs without any change. Okay. Now, if you look at the website of NVIDIA, QNumeric, this is the thing they are trying to do. It is not, it is a complex task. Huh? I mean, so this is called auto parallelization. User does not need to know, user just says, well, I want to run on 16 GPUs, it will run it. So, it is not a easy work, and the code is, well, I don't believe it is working very well, but you can try. We will see whether we can spend some time on QNumeric in this course, but that is the idea. Okay. So, Numba is in that line of thought, but Numba you need to put some command. In QNumeric you do not need to do anything, that is the idea. Then we went to multiprocessing, multithreading and MPI in Python, and they have their differences in strategies. No? When some depend on thread, some depend on processor, some depend on division of data among processors, which okay. But you can't do MPI on, well, you can't do multithreading on multi-node, right. But you need to know what they are, and you decide yourself how much time you got, how much efficiency you need, and then I will get into it. So, CUDA is getting to be a very important right now, at least GPU programming. I would not say CUDA. We want to run the code on GPU, and I will tell you why. I mean, I have some illustrations why GPUs are fast. I think you got a fair idea, but I will try to tell more why GPUs are fast, and half of the best machines in the world on parallel programming are on GPUs, and lot of things are not being told. Like Google, all the things which is doing for number crunching or search, they are all parallel, and they are all GPUs. Okay. So, NVIDIA, AMD, the GPU suppliers, first customer of their product, new chips and new devices are these big companies, NVIDIA, Facebook, Amazon. They are the biggest customers or users of the GPUs. So, I think you need to learn, if you want to do supercomputing, this GPU programming. I will not say CUDA for certain. You need to know how to work with GPUs. Okay. So, one thing we know, that GPUs are fast, is no doubt is fast, but I did show you this code before. If you are plowing a field, which would you rather use, 3-song auction or 1024 chickens, right? And Cray went, this is by Seymour Cray, and Graham was fully convinced it should be auction, not these chickens, they are no good, and he made processors which were the best processor in that time. I mean, you recall this movie which I screened, well, I ran it here. I think every new machine was 10 times faster, 10 times faster. The objective was new machine will be 10 times faster, and he achieved it. Any case, then the time of chickens came, right. Parallel programming is chickens work, but if chickens are going here and there, they are not going to be very good, right. I mean, chickens going here and there is no good. So, this is what a good general can do. So, this is a GPU thing. So, everybody knows who this person is. Who is he? Rambo. Okay. The movies, right, Rambo 1, Rambo 2, Rambo 3. Okay. So, this guy is like Superman, okay, or strong auction. He can kill people, I mean, okay, but how many can kill? 20, 30, that will be too many, right? But he has stunts and he does lot of stunts and he does it. He is like CPU, okay? CPU is powerful, very powerful in fact, but it does one at a time. So, data comes and it can do things very fast. If it does not get the data, then it says, well, get me from here, and it is like lot of stunts it has to do. It is very general, CPU general as well. So, that is Rambo. But chickens, if used properly, okay. So, I do not know whether you have seen war films, you have seen this structure, army structures. How many people play war games? Well, many I am sure, but so these are square formation. Romans used to do it, okay, and the one Napoleon Bonaparte, okay, he is one of the best generals. He used it in Egypt. So, this is a big legend. Napoleon, if you look at his war stuff, super. Of course, we have more documents on what Napoleon did. So, his army, he made us this square. So, he was supposed to fight cavalry in Egypt, and super cavalry. I mean, this Egyptian cavalry was very good. So, he made this squares, and when this cavalry, he does not fire. I mean, they are rifles, no, I mean, these guns, and they will not fire until they come close and just fire. And he won this battle, because all these guys are firing simultaneously from all directions. So, what does not have to be Rambo? Okay, you have to basically follow this strategy if you want to do a super kill. Okay, in one shot, these guys are, all the soldiers are trained well, but of course, they can do only one thing, shoot when ordered. So, this is what is GPU. Okay. So, they are organized very well. It is not only they are just weaker chips or weaker processors, weaker cores, they are organized very well, and they do not need to do stunts. They should not do stunt. If they do stunt, that is that's all. If this guy says, well, I want to do stunt, if anyone leaves out of the square formation, done, dead. Okay, it will not work. So, these are one task they can do very well, and they should just obey order. Okay, that is what GPU cores are. Many of them, but they just do things, and the enemy also comes from all directions. So, here you will have the data all over, okay, and they just work on the data simultaneously. So, that is also a design. If you are very powerful, but this square, if one guy at a time comes, then that is it. Well, of course, this guy will, one guy coming at a time is no effective at all, but it is good, you can do things fast if you have many things coming simultaneously. Okay. And you can read more about this if you like. So, this is a difference between GPU and a CPU. So, this Rambo CPU takes data from cache, it can take it can process very fast, of course, and but it is one at a time, essentially one at a time. Of course, from cache it is coming, well, 8 at a time, but 8 is a 1 unit for me. Okay. So, one by one. If you have more CPUs, then also it basically come one by one. Well, actually right now I can correct myself that if you have more CPUs, then they have their own cache, but still there are 64 CPUs, 64 cache. It is not as good as 5000 CPU cores, GPU cores on a GPU, 5000. Okay. Now, they are even increasing, numbers is increasing further. So, 64 is no match for 5000 GPU cores. I mean, you can have 64 Rambos, they are not as good as this 3 square formation. And the data also is coming from a very organized manner. The registers and cache, they have the data, and these are immediately available in streams. So, we will I think we discussed it, but this analogy I thought was will be in your head, and that is the biggest difference between CPU and registers, a CPU and a GPU. So, just to recap, since we are restarting the GPU discussion, CPU has high clock speed, Rambo clock speed, and GPU has low clock speed, but low is not very low, it is 1 gigahertz and this is 4 gigahertz or 5 gigahertz, 4 times. CPU 4 to 64 powerful cores, but GPU are thousands of weak cores. This is single instruction, single data, one at a time, one instruction, but this single instruction multiple data. So, many soldiers having their guns and you just shoot, and it is called also called T is for thread. So, it can really do millions of threads. So, number of threads are less than 100. Each core can have 2 threads, but they are not very, I would say each core 1 thread in CPU. In GPU we can have thousands of tens of thousands of threads. Execute limited data per cache per cycle. Okay. So, data is coming, actually CPU is always hungry for the data, unfortunately at this point. But GPUs, this data comes in waves, and it can execute thousands of them in one shot. CPU of course can execute general code, like operating system is running by CPU. GPU cannot run operating system, no way, it is not meant for it. But whatever like graphics and supercomputing now, vector operations, okay, is basically doing vector operations very fast, vector and array operations, and suffers from cache miss. Cache miss is a big problem in CPU, and since data is coming in chunks, sometimes it does not get data what it wants, but then it can work on. So, it is a single instruction, like I am grading a answer book and I have only one strategy to grade. Okay. Then if I look for one roll number, is not there, then I look for another, I grade any number, any answer book, sorry. So, that is what GPUs do. If you do not get this data, I will work on the next data. So, cache miss or data miss is not there in GPUs. Okay. So, let us look at how programs look like. So, GPU program will be again very different than what MPI programs are. Okay. So, this is a very different strategy, and that is what CUDA does. Okay. CUDA code will be like this. So, your main program will appear like this. These are 4 or 5 components. So, it has 5 components. So, variable allocation. Okay. So, we allocate variables, but please keep in mind that this variable, some of it is there in CPU, some is in GPU. Your arrays, big arrays will be on GPU. Okay. So, variables will have 2 types of variables. I am going to run a code in the next class. So, variable allocation, then variable initialization and transfer to GPU. So, we have arrays, but I want to, well, you can initialize in a GPU also as well. Okay. But this data has to go into GPUs, because GPU will do this number crunching fast. So, these are accelerators, they can do that fast. So, you need to send it as soon as possible to GPU and let it do. And this parallel execution in GPU. So, they will this number crunching and transfer result back to CPU. So, this is CPU to GPU, your arrays are, by the way, we do not allocate on CPU, we allocate on GPU, but is done via pointers. I am not sure how many of you are comfortable with C pointers. C pointers are tricky, and you need to know C pointers well. Okay, that is for CUDA programming, pointers you need to know well. And after execution, this data is coming back to CPU, and after it comes to CPU, then you have to free the GPU memory. CPU memory are big typically, but GPU memories are not too big. The top machine A100 has a good memory right now, it is 80 GB, but this RTX cards or your gaming cards have 24 GB, that sort of memory. Okay. Compared to a server which has 1 TB of memory, like one node of our Param Sanganak has, I think, 256 GB memory. But V100, which is a GPU, which is I think only 32 gigabytes or 24 gigabytes of memory. Okay. So, 24 versus 256. So, this memory has to be saved or should be used optimally. Okay. So, the programs, so this program will be there in CPU. Well, so I please do not misunderstand me, the object code will run on GPU, right, because GPU will do the number crunching and it will do that work, but all the control is with the program in CPU. So, CPU say run it, take it, send data, all that will be done by CPU. So, all the commands will come from CPU. Okay. So, this is also an important part. These programs are sitting on in CPU, but it will ask the compiler to create a code for GPU and run on GPU. So, I think this you need to keep in mind. I mean, you can't you look at a code, if you do not know this paradigm or strategy, then you will be lost. So, variables declared in CPU and well, variables are declared in CPU, but they are also they reside in or they are sitting in GPU. They are not declared in GPU. GPU is basically doing the is offloading. Sorry, CPU is offloading to GPU, GPU is doing the work. So, computing into the code segments are executed in GPU. GPU codes are compiled in GPU. Okay. So, well, those codes are object codes are there in GPU. Results are written back and forth between CPU and GPU. So, there is a memory, there is a transfer of data. So, CUDA programs are written in C and Fortran both. We will do it on C. Okay. So, there are Fortran codes as well.